Okay. So in the previous classes, Dtft formula and some basic problems and some advanced level problems we have solved using Dtft. Okay. So in today's class, I'll try to complete this Dtft topic, and I'll list out the properties of Dtft and followed by some problems. Property number 1. So this property available for all the mathematical tools, starting from exponential Fourier series, right? Linearity property. What is linearity property says? Suppose x1 of n, a signal. So if you find Dtft of this x1 of n, let's consider the representation of result Dtft is x1 of e power j omega. Suppose x2 of n, if we apply the Dtft, let's assume x2 of e power j omega. Now the linearity property says a constant a1 multiplied with x1 of n plus a2 multiplied with x2 of n. Now if we apply the Dtft for this entire signal, the result would be equal to a1 x1 of e power j omega plus a2 x2 of e power j omega. Okay, so this is linearity properties of Dtft. Property number 1. Next, property number 2. Periodicity principle. It's a very important property of Dtft. We have not drawn the spectrum so far, but actually we should draw the spectrum for x of e power j omega. How to draw the spectrum? We know already. In Fourier transform, we have drawn the spectrum. That is modulus x of e power j omega. And angle of x of e power j omega. Magnitude spectrum, phase spectrum. Okay. So the periodicity property regarding the magnitude spectrum. X of n may be anything. X of n may be a aperiodic signal. But if you find the Dtft of the particular signal and trying to plot the magnitude spectrum is periodic with every 2 pi. So I'll write down the statement. The Dtft of any signal is periodic with a periodicity of 2 pi. E power j omega plus 2k pi. Okay. K is an integer. Even x of n may be a periodic signal, but after finding the Dtft of that particular signal, if you try to plot the magnitude spectrum follows the periodicity principle. Okay. What is the total time period? 2 pi. For every 2 pi, the same kind of shape will be repeated again and again. So this is periodicity principle of Dtft. Next one, time shifting property. So this time shifting, time reversal, frequency shifting, differentiation, all these property already we discussed in Fourier transform as well as in Laplace transform also. Time shifting property. X of n, let assume x of n, Dtft result is x of e power j omega. So time shifting property says, suppose x of n minus k. Suppose x of n minus k, the Dtft result will be equal to e power minus j omega k x of e power j omega. Okay. Similar with your Fourier transform. Next, frequency shifting property. frequency shifting property. X of n. Let us assume the Dtft result is x of e power j omega. Suppose if we find Dtft of x of n multiplied with e power j omega naught n. X of n multiplied with e power j omega naught n. Now the result will be equal to x of e power j, this omega replaced by omega minus omega naught. So this property called as frequency shifting property. Because there is a shift in the frequency component in the result. Instead of omega, the result is omega minus omega naught. If suppose if you multiply x of n dot e power minus j omega naught n, then omega plus omega naught is the result. Next, time reversal property. That is x of minus n. What is the Dtft result of x of minus n? X of n Dtft x of e power j omega. So if we find Dtft of x of minus n replaced by minus n, so in the result x of e power j omega equation, wherever e power j omega is there, we have to replace by e power minus j omega. That's it. Okay. This is time reversal property. Next, differentiation in frequency. Differentiation in frequency domain, or differentiation in frequency. So differentiation property says x of n Dtft result is x of e power j omega. N times of x of n. The Dtft result is j d by d omega of x of e power j. Okay. So using this property, we can solve the problem. Using all the above property, n times of x of n. Now Dtft result is j d by d omega of x of e power j omega. Next, convolution property. So in Fourier transform, Laplace transform, we discussed the same property. We are finding the Dtft of convolution between two signals. Say for example, x1 of n convolution with x2 of n, and convolution with x3 of n, and so on. Suppose if we find the Dtft of this signal, the result will be equal to multiplication of their individual Dtft. x1 of e power j omega multiplied with x2 of e power j omega. This is the result. Convolution in time domain, multiplication in frequency domain. Similarly, multiplication property. Suppose two signals are multiplied in time domain, then the result is convolution in frequency domain. Okay. I'll write down here. Multiplication property or convolution in frequency domain, both are same. x1 of n convolution with x2 of n. Result is x1 of e power j omega dot x2 of e power j omega. Suppose x1 of n multiplied with x2 of n. Now if we apply the Dtft, The result is convolution in frequency domain. 1 divided by 2 pi x1 of e power j omega convolution with x2 of e power j omega. Okay. So convolution property, multiplication property, or convolution in frequency domain property. Fourier transform, Laplace transform, Dtft, Z transform, almost same property, except initial value theorem, final value theorem, which is available in Laplace transform and Z transform only. Okay. Remaining all properties are applicable for all the mathematical tools. So convolution property and multiplication property remaining not required that much. And the very important property at last, Parseval's theorem. Okay, so this Parseval's theorem, very important property and applicable for all the mathematical. So what does the Parseval's theorem state? To find energy of a signal using Dtft. So what is the formula we discussed in unit 1? To find energy of the signal, summation, discrete time signal, summation x of n whole square from n varies from minus infinity to infinity. So this is the formula we used to find energy of the signal in unit 1. Suppose using Dtft, if you want to find the energy spectrum of a signal, then the formula is 1 divided by 2 pi integration minus pi to pi x of e power j omega square into d omega. So this is Parseval's theorem. Okay. Same property we discussed in Fourier transform, and proof also I provided for Parseval's theorem particularly because it's very important property. Remaining proof you can understand easily by reading the reference books or textbook. Parseval's theorem is very important among all the properties. In general, if they are asking write any 4 properties of Dtft and prove it, then you may select any some easy properties and for solving or for proving that. But most of the cases I could see the Parseval's theorem property either from Fourier transform or Laplace transform or Z transform or Dtft continuously it's coming in the question paper. Are asked in the question paper. Right? So please concentrate on these properties definition as well as proof for each and every property. So with this, we'll try to solve some problems. Okay. Example. Find the convolution of the signal given below using Dtft. Okay, using Dtft. So x1 of n 1 by 2 power n u of n, x2 of n 1 by 3 power n u of n. Okay, find convolution. So actually in LTE system output equation we have derived, that is y of n equal to summation x of k h of n minus k, where k varies from minus infinite to infinite. This is represented by x of n convolution with h of n. This is what we have derived in unit 2, discrete time LTE system. Okay. But we are not going to use this particular formula. That is x1 of k dot x2 of n minus k, where k varies from minus infinite to infinite. We are not going to use this particular formula. Instead of this formula, we can apply the properties of Dtft, convolution properties of Dtft. What convolution properties of Dtft says? Dtft of convolution of signals is equal to multiplication of their individual Fourier transform. Okay, so if we find the inverse Dtft of the signal, we will get convolution result, right? Inverse Fourier transform of x1 of e power j omega dot x2 of e power j omega. Result is x1 of n convolution x2 of n. So rather than using the standard formula of convolution, what we are going to do, x1 of n convolution with x2 of n, Dtft result, x1 of e power j omega dot x2 of e power j omega. If we find inverse Dtft, inverse Dtft of x1 of e power j omega dot x2 of e power j omega, result is convolution, x1 of n convolution with x2 of n. So what we need to do now, you may got some idea. x1 of e power j omega first find, x2 of e power j omega find out, then multiply these two information x1 dot x2, and then take idft by partial fraction method, we will get convolution result. Okay, very simple formula only we are going to use, that is a power n u of n formula, fundamental formula. What is the result? A power n u of n, Dtft result 1 divided by 1 minus e power minus j omega, or otherwise we can write it as just multiply e power j omega on both sides, numerator and denominator. I think somebody started recording, I think so. I just once again request the student, please don't record the video without my knowledge. Many videos are missing. Multiply e power j omega on both numerator and denominator. So what you will get? E power j omega divided by e power j omega minus 1. Okay, so we may use either this particular formula or the second formula. Okay, e power n u of n, sorry, a divided by 1 minus e power, right? One divided by 1 minus a e power minus j omega. 1 divided by 1 minus a e power minus j omega. 1 divided by 1 minus a e power j omega. Okay, so if you multiply e power j omega both numerator denominator, e power j omega divided by e power j omega minus a. Okay, so remember this particular formula. We are going to use this formula only during the partial fractional method. Okay, so x1 of n, 1 by 2 power n u of n. What is x1 of e power j omega? A power n u of n. The result is e power j omega divided by e power j omega minus a. Okay, so e power j omega divided by e power j omega minus 1 by 2 minus 1 by 2 x2 of e power j omega, e power j omega divided by e power j omega minus x2 of n 1 by 3 power n. So 1 by 3 as per the formula. Use this particular formula. Okay. Now we need y of n. First y of e power j omega. Y of e power j omega, let us assume x1 of e power j omega multiplied with x2 of e power j omega. So multiply these two, x1, x2. E power j omega divided by e power j omega minus 1 by 2. E power j omega divided by e power j omega minus 1 by 3. Okay. Now we have to do the partial fractional method. And please remember, while solving Dtft and Z transform, Dtft and Z transform, partial fractional method, we always keep e power j omega, 1 e power j omega left side, denominator. Similarly, Z transform, we always keep 1 Z denominator of left side during the partial fraction. Please remember this. Why? Because we have the standard formula. The result is e power j omega divided by e power j omega minus e. Okay. At last step, we will multiply this e power j omega right side. Is that right side? Okay. So remember this particular point, Dtft as well as Z transform. What I'm going to do, I wanted to keep 1 e power j omega left side of denominator. Okay. So your resultant equation is e power j omega divided by e power j omega minus 1 by 2. Why I'm keeping this? At last step, I will multiply this e power j omega again to right side, so that I will get the formula e power j omega divided by e power j omega minus a format. Then, okay. Now partial fraction. Apply the partial fractional method. So two simple poles, a divided by e power j omega minus 1 by 2 plus b divided by e power j omega minus 1 by 3. Okay. So solve it, partial fractional method, and find out AB. E power j omega equal to a times of e power j omega minus 1 by 3 plus b times of e power j omega minus 1 by 2. If we multiply this particular term right side, you will get it. So in this equation 1, substitute e power j omega value, some value. Substitute e power j omega equal to minus 1 by 3. So minus 1 by 3 equal to 0 plus b minus 1 by 3 minus 1 by 2. Okay. And solve this. So minus 1 by 3 equal to b times of, if we take the common factor 6. Okay. So minus 2 minus 3. Right. 2 times of 3. Okay. Minus 1 into 2 minus 2 minus 1 into 3 minus 3 3.6. Right. Okay. So minus 1 by 3 b minus 5 by 6. Okay. So minus minus will be cancelled. Find the value for b. 1 by 3 already available. Now 6 by 5. 3, 2 times of 3. B equal to 2 by 5.
Sir,
I think, yeah, tell me.
plus 1 by 3 substitute చేయాలి కదా సార్?
Plus 1 by 2?
Plus 1 by 3 substitute చేయాలి కదా సార్?
Sorry.
A0.
Yeah, sorry. Sir, I'm confusing. I'm getting answer right. If you substitute plus 1 by 3, then it feels right. Thank you. So plus 1 by 3. Now what will get? Plus 2, right? Plus 2 minus 3. Okay. Right. I should get b value 3 actually. Right. Plus 1 by 3. So that this a term will be cancelled, right? So 3 minus 2. Plus 1 by 3 minus 1 by 2. So 2 to 1, 3 minus 1 minus 3 divided by 3 minus 2, 6. Left side 1 by 3 only. B value minus 1 by 6. Okay. So minus 1 by 6. So 3, 3. 2 times of 3. So B equal to minus 2. Right. Okay. So similarly, substitute e power j omega equal to plus 1 by 2. So that b value will be 0. We can find a value. And equation number 1. So 1 by 2 equal to a 1 by 2 minus 1 by 3 plus 0. Now find out the value for a. 1 by 2 a cross multiply 3 minus 2 divided by 6. Okay. So 1 by 2 equal to a times of 3 minus 2, 1 by 6. So 2, 3. So a value 3. Same. As usual, partial fractional method. Here the variable is e power j omega. Okay. In continuous time Fourier transform j omega. The Laplace transform s. Dtft e power j omega. Z transform z. But the method is same. So we have to use the appropriate formula. Now substitute a value, b value. Y of e power j omega divided by e power j omega. We already kept 1 e power j omega in the denominator of left side equation. So therefore, y of e power j omega divided by e power j omega equal to 3 divided by e power j omega minus 1 by 2. Okay. Minus 2 divided by e power j omega minus 1 by 3. Now you multiply this e power j omega right side. So that we will get the formula. e power j omega divided by e power j omega minus 1 by 2. Minus 2 into e power j omega divided by e power j omega minus 1 by 3. Okay. Now we got the formula. So at the final step, take inverse Dtft. You will get y of n. That is your convolution result. Y of n equal to x1 of n convolution with x2 of n as per the property. So 3 is a constant. 1 by 2 power n u of n. Minus 2 is a constant. 1 by 3 power n u of n. So this is your convolution result. So if we perform convolution using standard formula, that is x1 of k dot x2 of n minus k, from k varies from minus infinite to infinite. Okay, k versus x1 of k, k versus x2 of k, then k versus x2 of minus k, then k versus x2 of n minus k diagram. Okay, that problem we discussed in unit 2. So if we follow that method also, we will get the same result. So sometimes in the examination they will ask you find the convolution between these two signals using the standard formula of LTE system output equation and compare that result with any one of the transformation techniques. You will get the same result. Okay. So processing the signal in frequency domain is much simpler. See, if we go this method, say how many multiplication, how many additions are involving there. But same signal we process it in frequency domain. Just Dtft of individual signal multiply each other and then partial fraction. Finally apply the inverse Dtft. You will get the convolution between two segments. So this is nothing but x1 of n convolution with x2 of n. This is your result. Okay. So please remember Fourier transform, Laplace transform, Dtft, Z transform. To find convolution between the signals, you have to follow this procedure. Formula will be differ, and keep 1 e power j omega always left side, denominator of left side, for Dtft and also for Z transform. In Z transform, h of z by z. Okay. Next. Okay. Difference equation or solving discrete time LTE system. Described by difference equation. In continuous time LTE system, the characteristics of the LTE system represented by differential equation, right? D square y of t by dt plus dy of t by dt and so on. Similarly, a discrete time LTE system. What is discrete time LTE system? The input to the signal, say x of n, the output of the system is y of n, and impulse response of the system is h of n. Okay, so the relation between x of n, y of n of discrete time LTE system may be written by difference equation. Say for example, y of n equal to 1 by 3 x of n plus x of n minus 1 plus x of n minus 2. Okay, it means the output of LTE system y of n is equal to 1 by 3 times what input we applied x of n plus the same input delayed by 1 unit of time, the same signal delayed by 2 unit of time. This one simple example I'm taking. So any discrete time LT system can be represented by a difference equation. So this equation called as difference equation. Okay. And parallelly, suppose Dtft analysis, x of e power j omega, right? Output side, y of e power j omega. This is h of e power j omega. So the transfer function of discrete time LT system, h of e power j omega equal to y of e power j omega divided by x of e power j omega. Same formula we solved in continuous time Fourier transform. Here the notation is difference, that's it. Concept is same. Transfer function of a system is equal to transform of output of the system to transform of input of the system. It may be any transform tool, Fourier transform or Laplace transform or result transform. H equal to y by x. So from this relation, we can find h of n. Inverse Dtft of this equation, you will get h of n, right? Suppose y of n I need. What do we need to do? Y of e power j omega equal to h of e power j omega multiplication with x of e power j omega. Then take inverse Dtft. Suppose x of n you want to find out from the given h of n, y of n. Then x of e power j omega equal to y by h. Understand, no? Basic equation this one, h equal to y by x, y equal to h into x equal to y by h. So using this relationship, you may solve the problem depending on the questions. So I'll take the first example. A discrete time LT system described by the difference equation, y of n equal to and so on. Find a transfer function of the system or frequency response of the system. Both are same. Because to draw the frequency response, we have to find a transfer function first. Okay. Find a transfer function. So at this step, we are going to use the property. What property? Time shifting property. In Dtft, time shifting property. See, x of n e power j omega. X of n minus e power minus j omega k x of e power j omega. This property we are going to use now. Okay. So find Dtft of the given difference equation. Y of n become y of e power j omega. Dtft representation 1 by 3. X of n became x of e power j omega. X of n minus 1. Dtft result is e power minus j omega x of e power j omega. According to the property. X of n minus 2. E power minus 2j omega x of e power j omega. Okay. So transfer function h equal to y by x. So y of e power j omega equal to 1 by 3 take x of e power j omega outside. So 1 plus e power minus j omega plus e power minus 2j omega. Y of e power j omega divided by x of e power j omega. That is your transfer function of the system. So result is 1 plus e power minus j omega plus e power minus 2j omega divided by 3. So this is your transfer function of the system. So how to find transfer function of an LTE system from the difference equation? Just apply the DTFT, separate y term x term, then find y by x relation. That will give the transfer function of the system. So similarly, many problems are there. I will solve one more problem in difference equation solving. Consider a causal and stable LTE system whose input x of n and output y of n are related through the difference equation. Y of n minus 1 by 6 y of n minus 1 minus 1 by 6 y of n minus 2 equal to x of n. Okay. Determine frequency response. Determine frequency response, h of e power j omega. Determine impulse response. Impulse response meaning what is h of n? Okay. Let's consider the given difference equation as equation number 1. Find DTFT. Find DTFT of equation number 1. Y of n becomes y of e power j omega minus 1 by 6. Y of n minus 1 e power minus j omega y of e power j omega minus 1 by 6. Y of n minus 2 e power minus 2 j omega into y of e power j omega equal to x of n become x of e power j omega. So this is a DTFT of the equation 1 using time shifting properties of DTFT. So transfer function y by x, y of e power j omega, take outside commonly. So 1 by 6 e power minus j omega minus 1 by 6 e power minus 2 j omega equal to x of e power j omega. So y of e power j omega divided by x of e power j omega. This is your transfer function or frequency response, y by x. The result is 1 divided by 1 minus 1 by 6 e power minus j omega minus 1 by 6 e power minus 2 j omega. So this is the answer for first question. Find the transfer function or impulse response of the system. Next one, frequency response of the system. Next one, find the impulse response of the system. That is h of n. Okay. So for finding h of n, again we have to do the partial fractional method. First, convert this equation in the form of e power j omega. Suppose if you multiply e power 2 j omega on both numerator and denominator, e power 2 j omega divided by e power 2 j omega minus 1 by 6 e power j omega minus 1 by 6. Okay. Convert the given equation e power j omega formula. All are positive value. Next. What I told you, partial fractional method, particularly while finding the inverse DTFT, you keep always 1 e power j omega in the denominator of left side I need 1 e power j omega. Even right side, if the term is not there, you just multiply the e power j omega term in both numerator and denominator and take that e power j omega left side. Okay. So e power 2 j omega is there. E power 2 j omega. Can you write like this? E power j omega dot e power j omega. E power a dot e power b equal to e power a plus b, right? So j omega 2 j omega. So I have taken 1 e power j omega left side. So only 1 e power j omega available on the right side on numerator. So factorize this equation. Forget about the e term and all, right? You consider this is x square. E power 2 j omega consider as x square. X square minus 1 by 6x, ax square plus bx plus c format. Consider e power j omega as a x term here in the denominator. So now what are those two factors? Multiplication of two number is minus 1 by 6. Addition of two numbers should be minus 1 by 6. E power j omega minus 1 by 2 e power j omega plus 1 by 3, right? So minus 1 by 2 multiplication with plus 1 by 3, minus 1 by 6. If you add together minus 1 by 2 plus 1 by 3, you will get minus 1 by 6. So the factors are minus 1 by 2 plus 1 by 3. Okay. Now usual procedure. A by e power j omega minus 1 by 2 plus b by e power j omega plus 1 by 3. So partial fraction. E power j omega left side. Bring all this denominator term to right side, then it will be multiplied with the first term and the second term. So what is the result? A e power j omega plus 1 by 3 plus b e power j omega minus 1 by 2. Okay. So consider equation number 1 or equation number 2. Substitute e power j omega equal to minus 1 by 3. And find the value for b. Similarly, substitute e power j omega by plus 1 by 2. Find the value for a. E power j omega equal to 1 by 2. Okay. And you will get a value one by 2, right? Solve it. You get a value 3 by 5 and get b value a value 3 by 5 you will get. If you substitute 1 by 2, you get b value 2 by 5. Substitute minus 1 by 3, a will be cancelled, you will get b equal to 2 by 5. H of e power j omega divided by e power j omega. Write down h of e power j omega divided by e power j omega. So EAB value done. So what is a value? 3 by 5. 3 by 5 divided by e power j omega minus 1 by 2 plus 2 by 5 divided by e power j omega plus 1 by 3. Okay. Now multiply this e power j omega right side. So h of e power j omega 3 by 5 is a constant. E power j omega divided by e power j omega minus 1 by 2 plus 2 by 5 is a constant. E power j omega divided by e power j omega plus 1 by 2. Now impulse response, h of n from h of e power j omega. Remember the formula, e power n u of n. The result is e power j omega divided by e power j omega minus a. Let us assume this is equation number 3. Find inverse Dtft of equation number 3. So h of e power j omega became h of n. 3 by 5. 1 by 2 power n u of n plus 2 by 5 plus 1 by 3 is 0. So you have to put minus 1 by 3 power n u of n. Okay, because a power n u of n formula e power j omega divided by e power j omega minus a. Okay, but here plus 1 by 3 is 0. So that is equal to minus of minus 1 by 3, right? So you may take this particular term as a power n u of n. Okay, second step for this particular term, how to write the answer. E power j omega minus of minus 1 by 3. You will get this format. So e value minus 1 by 3, minus 1 by 3 power n. This is impulse response of the system. Okay, so h of j omega, h of n. Suppose in the same difference equation, assume x of n. X of n is some value. Then what is y of n? Note. So you should ready to solve any kind of problem using this relation. Already in Fourier transform, Laplace transform we discussed. Suppose I need to find y of n for given x of n. So you should get the expression for y of e power j omega first. Y equal to h of e power j omega x of e power j omega, right? So h of e power j omega, definitely you will solve from the given difference equation. X of e power j omega from the given x of n. Okay, now apply the partial fraction and finally find the inverse transform, we will get y of n. Understand? This is one method. Suppose from the same expression, x of n, what is x of n? Y of n given. What is x of n? So x of e power j omega equal to y of e power j omega divided by h of e power j omega. Okay. Y of n will be provided. From y of n you can calculate y of e power j omega. H of e power j omega from the difference equation. Then apply inverse Dtft, you will get x of n. So please remember this concept. This will be applicable for Fourier transform, Laplace transform, Z transform. Almost we covered. One more problem. Consider a system consider a system consisting of cascade of two LTA system. Cascading means series connection. One by one. Two LTA system with frequency response. H1 of e power j omega. H1 of e power j omega equal to 2 e power minus j omega divided by 1 plus 1 by 2 e power minus j omega. Similarly, H2 of e power j omega 1 divided by 1 minus 1 by 2 e power minus j omega plus 1 by 4 e power minus 2 j omega. Find the difference equation. Find the difference equation describing overall system. So the previous two problems, difference equation provided, and we found the transfer function h of e power j omega, right? Now h of e power j omega provided. So we have to find out difference equations. First, let us understand the question. The problem statement, there are two LTE systems. First LTE system transfer function, h1 of e power j omega. Second LTE system transfer function, h2 of e power j omega. They said both LTE system connected in cascade manner, like this. This x of n, y of n. This system impulse response h1 of n. This system impulse response h2 of n. Okay. Now they are asking what is the relation between y of n, x of n in difference equation. Okay. So in unit 2 we studied LTE system connected in cascade. LTE system connected in cascade, particularly in frequency domain. In time domain, it convolution, okay. But in frequency domain, it is now multiplication. So I will simplify this. These two blocks written as like this: x of n, y of n. Okay. Now result is h of e power j omega equal to h1 of e power j omega dot h2 of e power j omega. In frequency domain, LTE system, we are solving in frequency domain. Same if you try to solve in time domain, then your net result will be equal to h1 of n convolution with h2 of n. Okay. You got an answer now? So this is the overall idea now. H of e power j omega must be equal to multiplication of the h1, h2. Then we have to write the difference equation. So h of e power j omega equal to h1 2 minus e power minus j omega divided by 1 plus 1 by 2 e power minus j omega. H2 given in the problem 1 divided by 1 minus 1 by 2 e power minus j omega plus 1 by 4 e power minus 2 j omega. Okay. Now multiply this and solve it. 2 minus e power minus j omega numerator So denominator you have to solve step by step. First multiply all entire this term with 1 dot this value plus 1 by 2 e power minus j omega multiplied with all this value, and then simplify each and every term. So I hope you will get finally 1 plus 1 by 8 e power minus 3j omega. You just multiply and solve it. Your net impulse, net frequency response, h of e power j omega 2 minus e power minus j omega divided by 1 plus 1 by 8 e power minus 3j omega. Okay. Now from this, how to write difference equation? We know h equal to y by x, right? Output of LTE system, Dtft input of LTE system. So 2 minus e power minus j omega divided by 1 plus 1 by 8 e power minus 3j omega. Now cross multiply. And write down the result. Y of e power j omega plus 1 by 8 y of e power j omega into e power minus 3j omega plus 2 equal to equal to 2 times of x of e power j omega minus x of e power j omega multiplied with e power minus j omega. Okay. Now write down difference equation. Let's consider this is equation number 1. Apply inverse Dtft. Inverse discrete time Fourier transform. Y of e power j omega become y of n, right? Plus 1 by 8 is a constant. So e power minus 3j omega y of e power j omega. This is nothing but y of n minus 3 equal to 2 x of n minus e power minus j omega x of e power j omega. That is equal to x of n minus 1. Okay. So this is the desired difference equation of the given LTE system connected in the cascade manner. Okay. So from the transfer function to difference equation, particularly in this example, 2 systems are given. Suppose if only one transfer function given, then your work is simple. Replace h equal to y by x, cross multiply, and apply the inverse Dtft. Write down your difference equations. Okay. So that's all about Dtft problems, maximum possible problems. So any doubts? So Z transform is a pending topic in unit 4. So shall we start now? The transform or next class will discuss?